Hey, how are we? There is our learning target. It says I can distinguish between different types of parallelograms. So let's begin with this warm-up here. It says to explain why the two figures below are parallelograms. So I'm giving you a square and a rectangle, and I want you to use the definition of a parallelogram to explain why these figures are parallelograms. So one thing you could have written is these two figures are parallelograms because both figures are quadrilaterals with opposite sides parallel. By definition, that is a parallelogram. So if you go back to our definition of parallelograms, which I gave you in our previous videos, a parallelogram is a quadrilateral with both pairs of opposite sides parallel. These figures satisfy that criteria. The square is a quadrilateral with opposite sides parallel, and that's indicated with the arrows here. And a rectangle is also a quadrilateral with opposite sides parallel. So these two figures are types of parallelograms. This diagram here shows the relationships among special quadrilaterals. Now, I want you to notice that rectangles, rhombuses, and squares all fall under the category of parallelogram. So a rectangle, square, and a rhombus, they are types of parallelograms. They fall under that category. All right? All right, let's continue. These are properties of parallelograms, rectangles, rhombuses, and squares. And these are properties that you have to memorize for tomorrow because you will be quizzed on these properties in the beginning of the period. So make sure you memorize these properties. Make sure you know how to distinguish between the special types of parallelograms. All right, let's go over the properties. We've looked at the properties of parallelograms already in our previous videos. A rectangle has all the properties that a parallelogram has. So opposite sides are congruent, opposite sides parallel, so on and so forth, all that good stuff. In addition to that, in a rectangle, all angles are 90 degrees, and the diagonals are congruent. And this is what a rectangle generally looks like. A rhombus has all the properties of a parallelogram, and in addition to that, in a rhombus, all the sides are congruent. So in a rhombus, all the sides are congruent. The diagonals are also perpendicular. So if I draw the diagonals of this rhombus, these diagonals make 90-degree angles. So this is a 90-degree angle there, 90-degree angle there. Now let me make that look more like a box. Right, 90-degree angle. And then also the diagonals bisect the angles. And what that means is this angle here is going to be equal to this angle here. So these two angles are equal to each other. So are these. This angle will be equal to this angle. And so will this one be equal to this one. So will this one be equal to this one. A square has all the properties of a parallelogram, rhombus, and a rectangle. The more prominent properties for a square that people talk about, obviously all sides are equal, all the angles are 90 degrees, but then also the diagonals are congruent, just like in a rectangle. The diagonals are perpendicular, just like in a rhombus. The diagonals bisect the angles, just like in a rhombus. And so look, these properties here that I just covered, you need to memorize them. You gotta know these properties like the palm of your hand. All right, so let's use these to answer some questions. Example 1, which statement is false? All parallelograms are quadrilaterals. Yes, that's true. All parallelograms have 4 sides. All rectangles are parallelograms. Yes, that's true. All rectangles are parallelograms. Choice 3 says all squares are rhombuses. This is also true. Let me explain why. A square has all the properties that a rhombus has. Therefore, a square is a rhombus. The next one, choice 4, all rectangles are squares. This is false. The reason why this is false is because not all rectangles have the properties that a square has. Right? So a rectangle can't be a square because in a rectangle the diagonals do not bisect the angles, or the diagonals are not perpendicular, and so on and so forth. Right? A rectangle does not have all the properties of a square. That's the reason why choice 4 is false. So the answer to example 1 is choice 4. A rectangle does not have all the properties of a square. Example 2. Which quadrilateral does not always have congruent diagonals? An isosceles trapezoid always has congruent diagonals. If you go back to our isosceles trapezoid video, that's one of the properties of an isosceles trapezoid. A rectangle will always have congruent diagonals. Look at your properties chart. A rhombus will not always have congruent diagonals. So the answer is 3. A square will always have congruent diagonals. Example 3. Which quadrilateral has diagonals that always bisect its angles and also bisect each other? That would be a rhombus. It's not a rectangle because in a rectangle the diagonals do not bisect the angles. And it's not a parallelogram because that doesn't always happen with parallelograms. And it's not a trapezoid either because diagonals bisecting angles is not a property of isosceles trapezoids. Example 4 says, which quadrilateral does not always have congruent diagonals? An isosceles trapezoid does, a rectangle does, and it says does not always have, that would be a rhombus. And I mean, look, the other thing you could do is you can also draw a rhombus, and you will see that if you draw the diagonals, you'll see that this diagonal is going to be longer than this one. Example 5. In quadrilateral ABCD, the diagonals bisect its angles. If the diagonals are not congruent, so the diagonals are not congruent, quadrilateral ABCD must be. So I know that the answer is not a square because a square has that property that the diagonals are congruent, and I know the answer is not a rectangle because a rectangle has that property of congruent diagonals. So it's either a rhombus or a trapezoid. And the answer is rhombus because in a rhombus, diagonals bisect its angles. Example 6, given 3 distinct quadrilaterals, a square, a rectangle, and a rhombus, which quadrilateral must have perpendicular diagonals? Well, I know a rhombus does. And I know that a square has all the properties of a rhombus, so the answer is choice 3. It's not choice 2 because a rectangle does not have that property of perpendicular diagonals, therefore it also cannot be choice 4. So the answer is choice 3. Rectangle does not have perpendicular diagonals, so I could cross any choice with rectangle in it. Last one. Which reason could be used to prove that a parallelogram is a rhombus? Choice 1 won't do it because a rhombus does not have that property. Opposite sides are parallel. That won't prove it's a rhombus. That'll just prove it's a parallelogram. Diagonals are perpendicular. Yep, that will definitely do it. Because in a rhombus, the diagonals are perpendicular. Even though choice 4 is also true for a rhombus, sorry about that, choice 4 is also true for all parallelograms. And we want to be specific. We want to prove it's a rhombus, so choice 4 is not the answer. So the answer is choice 3. All right, I hope this video helps. Take care.